Hello, my dear friends of electronics. My name is Lorandt, and today I invite my colleague Frank. Hi.
Hi, Lorandt.
To make some measurements on some capacitors with different value. I see you bring two boards with you.
Yes.
And what is on first board? What you have on first board?
The first board is we have the same capacitance value for 2.2 microfarad, and we changing the voltage rating of the capacitor. So of course, we're starting with a class 1 ceramic to show the influence of this kind of ceramic. Then we have class 2 ceramic, X5R, X7R with 6.3 voltage and with 25 voltage. And to show the influence of different filter topologies, we also have a pi filter to show what's the influence of the DC bias on pi filter. Second board is to showing the same voltage level for here, especially 6.3 voltage, but we are starting with very high capacity values for 47 microfarads. It's really high capacity value for glass 2 ceramic, X5R, and we go down to 3.3 microfarad and show the effect of the DC bias.
Great. So first of all, we will measure with the agent and network analyzer with an internal DC bias source. And the first one is the NP0.
NP0, 10 nanofarad.
And you have a ferrite beads, and the ferrite beads are always the same value?
Yes, that's always the same, to have everything the same.
Scale, DC bias on.
And it's a 10 volt tube, you can go to 10 volt.
That's a 10 volt tube.
Yes.
Okay, so 0 volt, and then I will put now 10 volt. Now we have 10 volt and no change at all.
Yes, this is what we expected because class 1 ceramic is
NP0.
Yeah, has
Excellent.
no dependencies on voltage.
Next one.
So we make an X5R ceramics for 6.3 volt to show the dependencies. So this is also 2.2 microfarad. We can go up to 6.3 volt.
6.3 volt,
Yep.
this one. All right, let's go.
And we see there is an influence,
Very small.
but very small.
Very
so because it's a low capacitor value, the influence is not so high.
And the next one.
Next one is an X7R ceramic with 6.3 volt to show the difference between those two kind of ceramics. Here we can also go up with 6.3 volt.
6.3 as well.
And here also no really change in the characteristics. So
Extremely small.
yeah, extremely small. So we can go up to the rated voltage with filter.
If it's an X7R, it's no problem. The next
So the next one is a 2.2 microfarad 25 volt type. Now we go up to the up to 20 volt because of the measurement equipment, but now we can go in higher voltage level. So first
To
step maybe
20
10 volt.
All right.
So we see now, because it's because of the high voltage type, we have also a dependency on the capacitance.
Yeah.
So it
And
will
we can already
increase.
see the piezo effect already.
Right.
This is also there. So I will go up to 20.
Yes. So we see the influence increases when we go near the rated voltage.
And high piezo effect as well.
Yes.
Nice.
That's good to see. No measurement failure. It's from the ceramic. So at the end, the pi filter with 1 microfarad, 6.3 volt, to show that because we halve the capacitance value because of the pi structure, the influence is less, but the filter resonance frequency stays the same.
So the P filter, you have 2 times capacitor, each one 1 micro.
Yes.
This time, okay.
Also 6.3 volt. And we see, because
No
we
change?
halve the capacity, there's more or less no change. So this is a really good combination to do in pi filter.
So it's actually what I'm always saying in a seminar, you should use a P filter.
Yeah.
I like P filter, but I like pi filter.
P filter.
Now we have the second board.
Yes.
Again, there are same voltage, but different capacity values. So the first one is 47 microfarad.
Correct.
Okay. And let's go to 6.3 volt.
Yes. and now we see a massive impact of the
Absolutely.
Of the voltage.
And already at low voltage, 6.3 volt, the piezo effect is there.
Yeah.
Nice.
And we have capacity change more or less 50%, so this is really really high.
Next one,
So
please.
this next one is in 22 microfarad capacitor, also X5R, 6.3 volt. Here we
Yes,
see also the massive influence of the DC bias,
absolutely.
because it's also high capacity value.
Correct.
Now we use the third filter. The SND ferrite stays the same, of course, and the capacity value is about 10 microfarad capacitor. Also glass 2 ceramic X5R. Let's check the DC bias behavior. We can go also up to 6.3 volt.
Okay, now we have 6.3 volt. It's not that massive change on the voltage.
Yes.
Same voltage, but because of the capacitor size is now only 10.
Yeah, this
microfarad.
is the reason why the influence is not so big anymore, because the material can handle this DC bias effect much better.
Next one, please.
So the next one is an 4.7 microfarad capacitor, also 6.3 volt. Now we are moving in the smaller regions of the capacitive values, and let's see what happens. For
Just minimal change.
yeah. This is what we also see in the first board, that when we have low capacitance value, that the change is not so much.
And the last one value is?
Is a 3.3 microfarad capacitor, so we are going to the values from the first board.
Now, let's change.
We can also go up to 6.3 volt.
Just a little change.
Yeah, this is what we expected.
Exactly
because
expected.
We are going to the 2.2 microfarad, so that's it. So when you have high capacitance values, you have to check the DC bias curves.
Absolutely.
Especially, or the customer can do it with our expert tools. So we provide the data. So this is really necessary to check.
Okay. In our next videos, we will make all this simulation in LT-Spice. So please watch our next video for LT-Spice simulation as well, and hope you enjoy it. And please see you in our next videos. Bye bye.
Bye.